The next topic is galvanometer to a voltmeter. Galvanometer to a voltmeter. Galvanometer converted into a voltmeter. Voltmeter, yeah. Voltmeter is an instrument used to measure the potential difference across any 2 points in the electrical circuit. So, what is the uses of voltmeter? What is the purpose to use the voltmeter in an electrical circuit? A voltmeter is an instrument used to measure potential difference across any 2 points in the electrical circuits. So, it should not draw any current from the circuit. Otherwise, the value of the potential difference to be measured will change. Voltmeter must have high resistance. Please note it down, children. This is very important point. Voltmeter must have high resistance, and when it is connected in parallel, it will not draw appreciable current, so that it will indicate the true potential difference. So, when the high resistance connected in the series to the galvanometer circuit means the galvanometer automatically converted into voltmeter. So, low resistance connected in parallel means galvanometer converted into ammeter. Here high resistance connected in galvanometer series to the galvanometer means the galvanometer converted into voltmeter. This point is very important. Voltmeter must have high resistance, and when it is connected in a parallel, it will not draw appreciable current, so that it will indicate the true potential difference. Now, the galvanometer is converted into a voltmeter by connecting high resistance RH in series with galvanometer. So, the scale is now calibrated in volt, and the range of voltmeter depends on the value of the resistance connected in series. That is, the value of resistance is so adjusted that only current Ig produces full scale deflection in the galvanometer. Let Rg means galvanometer resistance, be the resistance of the galvanometer, and Ig, that is the galvanometer current, be the current with which the galvanometer produces full scale deflections. Since the galvanometer is connected in series with high resistance, the current in the electrical circuit is same as the current passing through the galvanometer. That means I is equal to Ig. Here I is equal to Ig is equal to Ig is equal to V by R. That means V means potential difference divided by total resistance. According to the Ohm's law, I is equal to V by R. V means potential difference divided by R is nothing but total resistance. Since the galvanometer and I resistance are connected in series, the total resistance or effective resistance gives the resistance of voltmeter. The voltmeter resistance is, what is the formula for the resistance in series? R is equal to R1 plus R2. Here RV, that is a voltmeter of resistance, is equal to R1 is nothing but galvanometer resistance plus R2 is nothing but I resistance connected in series. So RV is equal to RG plus RH. The next step is Ig is equal to V divided by total amount of resistance. Potential difference divided by total resistance is nothing but Rg plus RH. So Ig is equal to V by Rg plus RH. Now rearrange this step. RH is equal to V by Ig minus Rg. That means, note that galvanometer current is directly proportional to potential difference. That means galvanometer current is increases means potential difference also increases. Ig is directly proportional to V. The deflection in the galvanometer is proportional to the current Ig, but the current Ig is proportional to the potential difference. Hence, the deflection in the galvanometer is proportional to the potential difference. So, please note it down, this important point. The deflection in the galvanometer is proportional to the current Ig, but the current Ig is proportional to the potential difference. Hence, the deflection in the galvanometer is proportional to the potential difference. Since the resistance of voltmeter is very large, please note it down, this point. Since the resistance of the voltmeter is very large, a voltmeter connected in an electrical circuit will draw least current in the circuit. An ideal voltmeter is one which has infinite resistance. Please note it down, children, for your objective type. An ideal voltmeter is one which has infinite resistance. So key point of voltmeter, galvanometer converted to voltmeter means first point is voltmeter is a high resistance instrument and it is always connected in parallel with the circuit element across with the potential difference is to be calculated. Second point, an ideal voltmeter has infinite resistance. Infinite means very large resistance connected in series manner. The third point is in order to increase the range of voltmeter, n times the value of the resistance to be connected in series with the galvanometer is R is equal to n minus 1 into G. This formula is very important for your objective type question. In order to increase the range of voltmeter n times the value of resistance to be connected in series with galvanometer is R is equal, capital R is equal to n minus 1 into capital G. So once again repeat the key points. First point is voltmeter is a high resistance instrument and it is always connected in parallel with the circuit element across which the potential difference is to be calculated. Then an ideal voltmeter has infinite resistance. Ideal voltmeter means what is the condition? Has infinite resistance. The third point, in order to increase the range of the voltmeter, n times the value of resistance to be connected in series with galvanometer is capital R is equal to n minus 1 into capital G. Thank you.